Hey everybody, Mr. Rubo here. Today we're going to talk about factoring um, polynomials, and specifically there's two types of factoring we're going to talk about. Because we've talked about like product sum when we're talking about quadratics, we've done difference of two squares with quadratics, um, GCF with quadratics, which GCF with polynomials is the same thing. But now we're going to talk about two different types of factoring when it comes to polynomials. The first one is factor by grouping, or sometimes 2 by 2 factoring. So with this one, doesn't always, or you're not always able to do it, but when you are, it makes the factoring much, much quicker. So let's say we have this polynomial, so minus 3. All right, so here, first for factor by grouping, there has to be 4 terms because we're going to group them in twos. So there's a 2 and a group of 2 and a group of 2. So when we do this, you can usually look at the numbers and see like, hey, this will work, or hey, this might not work. But you might not notice it right away, so it never hurts to try factor by grouping, because if it does work, it's going to save us a lot of time. So you group, and then just like with product sum, we can do the GCF. So 40 and 8, GCF there is 8. And then with the x cubed and the x squared, GCF there is x squared. So we take that out, so we're left with 5x minus 1. And this one, we look and, oh, both have a 3, so we're going to take out a positive 3. So we get 5x minus 1. And now we know that factor by grouping works because our two parentheses are the same thing. So then we write the two parentheses as 1 because we're factoring it out, and then we write what's left over in its own set of parentheses. Helps if you write all the stuff. So 8x plus 3. All right, and then we have just factored this polynomial to these two factors. And then the last thing you would want to do is check to see if either one of these two can factor more. In this case, they can't. So to factor that, all right, we'd be done with the factoring. Okay. So the key here, though, is that these two things in parentheses have to be the same. If you start factor by grouping and they don't end up being the same, then it means we can't factor by grouping. Or it also could mean that maybe you didn't take out the GCF of both things. Or it could also mean, like, if you end up with the opposite, you should have taken out a negative then as well. Okay, so that's factor by grouping. The other type of factoring is there's two different ones here. There's difference of cubes and there's sum of cubes. So sometimes you'll see it abbreviated as docs or socs. Okay, so what these are is when you have something cubed, and for difference would be a subtraction, and then something else cubed. For socs, you're going to do same. It's going to look the same, except this time it's a sum. So with these guys, with cubes, we have a rule for difference and we have a rule for sum. Unlike squares, where there's only the difference of two squares, there's difference and sum for cubes. Okay, so for this, they're going to follow a very similar rule to factor. It's a little, what's it called? Just a rule. And so the way the rule is whatever this a value is and whatever this b value is, when it's subtraction, it's going to be a minus b, and then a squared plus ab plus b squared. Okay, and we'll do an example with numbers in a second. But then for the sum, it looks very similar. However, the two first operation, so the plus and the minus get switched. So there is a little acronym that might help you remember which goes with which, and it's going to be SOAP. SOAP. So what this means is same. So the first one, the first plus or minus sign is always the same as whatever you were dealing with. So here it's minus, so this was minus. This was plus, this was plus. O is for the second one, and it's always the opposite. So this was minus, this one's plus. If this was plus, this one's minus. Okay, and then the last one is the same for both, and it's where the AP comes in, which stands for always positive. Okay, so this last operation is always plus b squared. All right, so let's just do a quick example of this using. We'll do a couple. We'll do one of each. So we'll start with x cubed plus 8. So here, hopefully we can see that x cubed is definitely a perfect cube. 8 is a perfect cube because I could rewrite this as 2 cubed. Ooh, that didn't look good. So because I can write it as 2 cubed, it's a sum of cubes. So now my a value is x and my b value is 2. So we go ahead and do the factoring. So it'd be x plus 2 because it's the same. Then x squared minus, it's the opposite, 2x plus 4. Okay, and that's going to be our answer. That's the factor form. Okay. Yeah, and that's really what it comes down to. We'll do one more in here. So the last one I'm going to do is one that looks a little bit tougher, but it ends up being just using the formula. So 64x cubed minus 27. So we have a coefficient here. This coefficient has to also be a perfect cube. So in this case, that's 4 cubed. X cubed is perfect as well, and then 3 cubed is 27. So I can rewrite this as 4x cubed minus 3 cubed. So we can now clearly see 4x is my A, 3 is my B, and it's a difference. So it's going to be 4x, same sign, so 4x minus 3, and then 4x squared. Oops, let's make that look a little bit cleaner. So 4x squared, which we want to square both things, so we'll do that in a second. Opposite sign, and then 4x times 3, which is 12x, and then squaring that, and this is always positive, so it's positive 9. All right, so then our final answer will be 4x minus 3, and then 16x squared plus 12x plus 9, and then circle it, and we are done. Okay, so that right there is our answer. Okay, so yeah, in this video we went over factor by grouping and factoring with difference or sums of cubes, so dots or socks. Okay, so thanks for watching and have a good day.